Prometheus and Grafana. To add Prometheus and Grafana monitoring to your Node.js project, you'll follow these main steps. Step 1. Expose Prometheus metrics in Node.js. Install the Prometheus client. npm install prom client add metrics to your app. For example, app.js. Add the endpoint metrics which will return metrics using prom client library. Example, const client equals require prom client, const register equals new client.registry, client.collect default metrics register. Step 2. Run Prometheus. 1. Create a config file, prometheus.yml, with fields, global and scrape_configs. The field global has subfield scrape_interval, 5s. The field scrape_configs has a subfield job name. 2. Run Prometheus. Docker run name, Prometheus network, monitoring DP 9090 to 9090v. Prometheus.yml prom/Prometheus run, both containers Grafana and Prometheus, in the same Docker network. Docker network create monitoring. Step 3. Run Grafana. 1. Run Grafana Docker run network monitoring name, Grafana DP 3001 to 3000 Grafana/Grafana 2. Access Grafana open http://localhost:3001 default login, admin 3. Add Prometheus as data source. Go to settings data sources add data source. Choose Prometheus. Set URL to http://prometheus:9090 save and test. Step 4. Create dashboards in Grafana. Go to dashboards new add visualization enter a PromQL query. When you add a /metrics endpoint to your service using a Prometheus client library, like prom client for Node.js, you expose current state metrics in a text-based format. http://requests_total method equals get, code equals 404.3. This is called the Prometheus exposition format. Prometheus pulls the data, scrapes, parses, converts it into time series data, and stores the data in a time series database. Each metric point has metric name, labels, timestamp, value. You query with PromQL. You can build Grafana dashboards with PromQL queries to visualize metrics over time. Differences between Prometheus, InfluxDB, Datadog, and OpenTelemetry, as if you were architecting a modern monitoring system and deciding which tools to use. Imagine you're building a cloud-native microservices system, running in Kubernetes, with dozens of pods, APIs, and background workers. Your goal is to monitor system performance, catch failures fast, and understand what's going on under the hood, using the right tools for the job. You start with Prometheus. Prometheus is your first choice. It's open source, battle-tested in Kubernetes, and speaks a powerful language called PromQL. You deploy it inside your cluster, and it immediately starts scraping metrics from your services every few seconds. You expose metrics like http://requests_total method equals post, route equals API/login, status equals 200. This multidimensional label model lets you drill down on metrics, requests per route, status code, or user type. Prometheus is pull-based, meaning it reaches out to your services on a /metrics endpoint. This gives you full visibility and control, and makes debugging easy. Then you plug Grafana into Prometheus. Now you can build dashboards, track CPU usage, memory leaks, and HTTP errors visually. It's clean, fast, and cost-effective, but Prometheus has limits. It doesn't do tracing or logs. Scaling horizontally is manual. Long-term storage requires external solutions, like Thanos or Cortex. So, what if you want full observability? You add OpenTelemetry. Now you introduce OpenTelemetry, not as a replacement, but as a layer of instrumentation across your services. OpenTelemetry helps you standardize how you collect metrics, traces, logs. It doesn't store anything itself. Instead, it exports telemetry data to backends, including Prometheus for metrics, and Jaeger or Tempo for tracing. Now, every HTTP request not only exposes Prometheus metrics, but also generates a trace, a timeline of how long it took through your entire microservice chain. You can see the request come into your API, hit Redis, call another service, and return, all visualized in your trace backend. OpenTelemetry gives you standardized SDKs across languages, making it easy to instrument your Go backend, Node.js API, and Python workers all in the same way. You consider Datadog, but maybe you're tired of managing all this infrastructure. You look at Datadog, a commercial SaaS solution. It does metrics, logs, traces, synthetic monitoring, alerting, anomaly detection, all out of the box. With one agent installed, it pushes data to the cloud. No PromQL or scraping needed. You get polished dashboards, AI-driven alerts, 500+ built-in integrations, PostgreSQL, Redis, Docker, Kubernetes, and an intuitive UI. But that power comes at a cost, literally. High cardinality metrics can get expensive. You're locked into the platform. No control over the back-end infrastructure. So Datadog is great for teams that need full-stack observability fast and don't want to manage any of it themselves. Then you hear about InfluxDB. If your system processes high-frequency data, like sensor readings from thousands of IoT devices, Prometheus might not be ideal. It's optimized for ephemeral, recent metrics, not for storing years of high-resolution data. That's where InfluxDB shines. It's a time series database, built with a right-optimized storage engine, retention policies, and SQL-like querying via InfluxQL or Flux. InfluxDB lets you store every temperature reading, every vibration sensor, every event, retained for months or years. You might use Telegraph to collect and push this data, or write directly to the database. It's less focused on cloud-native microservices, and more focused on event stream analytics and IoT telemetry. Final thoughts. Each of these tools serves a different purpose in the observability stack. Prometheus is your go-to tool for real-time metrics in microservices. OpenTelemetry is your instrumentation glue. It brings metrics, traces, and logs into a unified view. Datadog is the turnkey solution. Plug it in, pay for convenience. InfluxDB is your long-term time series database for high-throughput event data. They're not necessarily rivals. In fact, they can work together. A robust stack might use OpenTelemetry for instrumentation, Prometheus for metrics, Grafana for visualization, Tempo for tracing, Loki for logs. Or replace all of the above with Datadog, if your budget allows. What is PromQL? PromQL is the query language used by Prometheus to retrieve and aggregate time series data. It's designed for monitoring, alerting, and dashboarding. Basic concepts. Term description. Metric A named time series, for example, HTTP_requests_total. Label key value pairs attached to metrics, for example, method equals GEG. Instant vector A set of time series with exactly one sample each at a single point in time. Range vector a set of time series with a range of data points, for example, last 5 meters. Scholar a single numeric value. String a string literal, rarely used directly. Query types. Instant queries. Query the current value of a metric. Up. HTTP_requests_total job equals API server. Method equals post-range queries. Query over a time range. Rate HTTP_requests_total 5 meters. Average _over_time CPU_usage 1 hour. Aggregation operators. Min, max, sum, count. Binary operators. Plus. Example. CPU_usage. CPU_capacity. 100. Functions. Function purpose example. Rate average per second increase rate HTTP_requests_total 1 meter increase, total increase over range, increase CPU_usage, 5 meters irate, instant rate irate network, _bytes 30s average_over_time average, in time range average_over. _time CPU_temp 5 meters max_over_time, max value max_over_time, load 15 meters, abs absolute value abs disk_usage clamp _min x, y, force min clamp _min CPU, 0. Common example spot on. Check if services are up. Up equals 0. 2. Total requests per second. Sum rate HTTP_requests_total 1 meter 3. CPU usage percentage. 100, 1. Average rate node underscore CPU underscore seconds underscore total mode equals idle 5 meters 4. Memory usage. Node underscore memory underscore mem total underscore bytes. Node underscore memory underscore mem available underscore bytes. 5. Alerting condition. Disk usage greater than 90%. Node underscore file system underscore size underscore bytes. Node underscore file system underscore free underscore bytes. / node underscore file system underscore size underscore bytes greater than 0.9.